Okay, today we will learn about relative velocity. What is relative velocity? Suppose you are sitting in a train and the train is moving towards west with 10 kilometer per hour speed, and you are seeing from the train that a tree outside is moving east towards east, but you know that this tree is not actually moving. You are seeing that tree is moving in opposite direction because you are sitting in a moving train. So we'll see this case math. So the velocity that tree got is relative velocity. Okay, we'll see this mathematically accurately. Okay, so the relative velocity, say w vector, is, this is a relative velocity. W vector denotes here relative velocity. That will be u vector, sorry, so it's v vector. V vector is the actual velocity of object minus u vector. What is u vector denoting here? Velocity of the observer. Okay, now let's see. We know that the tree is not actually moving, it is standing still. Tree cannot move, so the actual velocity of the tree will be 0 vector. Now the velocity of the observer who is observing the tree, the velocity, he is sitting on the train, the observer is sitting on a moving train, so the velocity of the observer is 10 kilometer per hours, and that is west. So suppose see, the east is positive x-axis, so this will be negative x-axis, so this will be u vector is minus I cap, so u vector will be 10 minus I cap, the direction is minus I cap, so the relative velocity of the tree will be 0 vector minus 10 I cap, so that will be plus 10 I cap. So the direction of relative velocity will be towards x-axis because this is plus I cap, and how much velocity it will get, the relative velocity, that is 10 kilometer per hour eastwards. So when you are sitting in a train which is moving 10 kilometer per hour speed westwards, so in sitting in that train you will see the tree is moving, the tree which is standing outside, that is moving with 10 kilometer per hour speed, and it is moving eastwards. So that is the relative velocity of the tree. Okay, now suppose you are sitting in the same train, but now another train is passing, and suppose you are seeing that this train is passing with 20 kilometer per hour speed in east direction. This velocity is, you are seeing, that is relative velocity. So what is the actual velocity of that train? So relative velocity w is what? 20, and this is positive x-axis, so 20 I cap equal to v vector. Actual velocity of the train we don't know, and we know the velocity of the observer, that is first minus, and this velocity is minus 10 I cap, because this is along minus I cap, so that 20 I cap. So that means v vector will be 20 I cap minus 10 I cap, that is 10 I cap. So the actual velocity of this train will be 10 kil. This velocity is relative velocity, what this observer is seeing, and actual velocity will be 10 kilometer per hour with eastwards. Okay. So actual velocity will be 10. So this train is passing 10 kilometer per hour speed eastwards, and this train is also passing 10 kilometer with 10 kilometer per hour speed westwards. So the both train is passing with same speed but in opposite direction. So they will see that this train will see that the another train is passing with, actually this observer will see itself as standing still, and the another train is moving with double speed. Okay. Okay, what will be your suppose you are sitting in this train, and what will be the relative velocity of you in your own eye? Okay, so what will be the relative velocity of you in your own eye? So that is w vector. V vector is the velocity of object. Here object is you who is sitting on this train, so the v vector is 10 I cap, 10 minus 10 I cap, that is the speed of the train, because if the train is moving with 10 kilometer per hour and you are sitting on this train, that means you are also moving with 10 kilometer per hour westwards. Minus u vector, u vector is the velocity of the observer, so that will be minus 10 I cap, and this will give you 0 vector. So that means the relative velocity of you in your own eye will be 0. That's the reason why we see ourselves when we are in a moving train. When we are sitting in a moving train, we see we see ourselves at rest. We think that we are not moving, the outside things are moving. Okay, this is because of this relative velocity concept. Okay, so now we'll see another problem. Okay, okay, now suppose suppose rain is falling vertically downwards with 10 kilometer per hour speed, and a man is moving towards east with 4 kilometer per hour speed. So this moving man So to this moving man, what will be the direction of the falling rain and what will be the speed of that rain from this man eyes? Okay, what this man will see, we are when we are, suppose we are standing still here and we seeing that the rain is falling directly downwards with 10 kilometer per hour speed. So now this man is moving with 4 kilometer per hour speed. Suppose he is cycling. So what will be the speed of rain in this man eyes? Okay, what this man will see, that in which direction rain is coming and uh, with what speed. So we'll see that. So here we have to find relative velocity of rain in the frame of this man. So that will be w vector will be the, what is the speed, actual velocity of the rain. That is, suppose you say you take a frame, this is positive x-axis and this is positive y-axis. So this is your I cap and this is your j cap. Unit vector along this axis is j cap, unit vector along x-axis is I cap. So that velocity of rain is 10 minus j, because this is downwards, the rain is falling downwards, so this is be minus 10 j cap minus u vector. What is u vector? 4 I cap. Okay, 4 kilometer per hour towards I cap. So that will be minus 4 I cap minus 10 j cap. Okay, this will be the resultant vector. So minus 4 I cap means towards the negative x-axis we have to go 4 unit. Suppose 1, 2, 3 and 4, and towards the negative y-axis we have to go 10 unit. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we have to add this, draw a parallelogram and add these two vectors. So this direction will be the, this will be the direction of falling rain from, so the man will see that rain is falling in this direction. Actually the drawing is not, okay, so this man who was moving is towards with 4 kilometer per hour speed, that man will see rain is not falling vertically downwards, but the rain is falling in an angle. Okay, and we have to find that what will be the angle of the falling rain. How we'll do that? From this vector we know how to find its magnitude, and what we have to still found that what will be the speed of the rain and which angle it is falling. So that will be modulus root over minus 4 square plus minus 10 square. So that is root over 16 plus 100 root 116. Okay, this will be the magnitude of the speed of the rain, and that will be a slight higher than 10 kilometer per hour speed. Okay, so this will be the relative speed of that rain what this man is seeing, and what will be the angle we know. this is theta, that means this is theta. So we know that sine theta, okay, tan theta is height by base, so tan theta will be height, that means 10 by 4, so 5 by 2, just 2.5. So theta will be tan inverse 2.5. So this will be the angle, and so in this angle the rain is falling, and this is the actually the rain is actually falling vertically downwards, but this man who is moving 4 kilometer per with 4 kilometer per hour speed eastwards, that man will see the rain is falling in an angle which is theta equal to tan inverse 2.5 with x-axis, this angle. So this man will see that rain is falling in this angle and with this speed. So that is the relative velocity of the rain in the eyes of this observer. Thank you.